Okay, we'll work through the solution to statics quiz 2. So we're given an assembly here. A flange is mounted to a surface, and at the center of the flange we have our coordinate system. So we have this in the x, y, and z directions. And we're told that we have a force F1 that's defined by coordinate direction angles alpha, beta, and gamma, and then F2 is in the negative y direction, acting here, and F3 lies in the xy plane in the negative x, positive y direction. We're asked for the coordinate direction angles alpha, beta, and gamma 1 of F1, so that the resultant force is negative 400k pounds. Then we get some points here for each force in Cartesian vector notation, 1 point for each component of F1, 1 point for the magnitude of F1, and then 1 point for each coordinate direction angle. Alright, so step 1, getting in CVN. So we'll start with F1, and I was looking for just something like this, Fx in the I direction plus Fy in the j direction plus Fz in the k direction, and that would have been sufficient. Some people went back and wrote the actual values of Fx, Fy, and Fz after they'd solved for them. In F2, what do we have here? Well, we have negative y, so we have nothing in x, nothing in z, just negative 200j. And if we want to be complete, we can put pounds on this. And then finally F3, we have in the negative x direction, so we have 400 outside, and we have, so this is 30, so in the x direction that's going to be sine 30, so negative sine 30 degrees, I plus cosine 30 degrees, j. It's also pounds. So that's what I'm looking for step 1, so that should get us a point here, and a point here. Now we're actually going to go solve. I should have put step 1. Step 2. Step 2, solve FR is negative 400k. So we know FR equals F1 plus F2 plus F3. So FR equals negative 400k equals F1 Fxi plus Fyj plus Fzk minus 200j, there's F2, and then finally plus 400 times negative sine 30 I plus cosine 30j. Alright, so then we can take that, solve that through. So we have in our k direction, this has to add up, so the only thing acting in k is Fz. So Fz equals negative 400k, and then we have 0 equals, so the 0, we're going to have the I is Fx, the I direction, and then this is also acting in I, that's sine of 30 is 1/2, so we're going to have negative 200 I, so Fx must be positive 200. There's that component, there's this component. Fy, we have positive Fy minus 200j plus, this value is going to be the cosine of 30 times 400, which is 346.4 equals 0. So we get 146, move that to the other side, so Fy was negative 146.4 pounds. It's pounds. Alright, so there's our three components. So that's our second part. Last part, step 3, magnitude. F1. So our magnitude is just going to be simply the square root of the squares of each of these. So we're going to have 200 squared plus negative 146.4 squared plus negative 400 squared. And I square all of those. Squared plus square root. I get 470.6 pounds. That's the magnitude of F1. So no vector symbol there. And now we can finally get to our coordinate direction angles. So step 4. So what are these? So alpha equals the inverse cosine of fx over f1. So what is that going to be? It's going to be 200 over 470.6. Inverse cosine of that thing. So that equals 64.8 degrees. So alpha 1. Beta 1. Inverse cosine of fy over f1. So that's going to be the inverse cosine. What's fy? Negative 146.4 over 470.6. So 146.4 negative divided by 470.6. So that's 108 degrees. Finally, gamma 1, inverse cosine of our z component over our magnitude. We get our negative 400 over 470.6. First cosine there is 148 degrees equals our gamma 1. So there you have it. So you could have gone back and written this thing here as our coordinates here, 200I minus 146J plus minus 400K pounds. You could have done that as well. That would have been sufficient as well. I was just really looking for this setup so that you had some variables to work with when you went to solve for them. So steps again, set it up in Cartesian vector notation, set our sum of our forces equal to our resultant, which was given to us as this 400 negative in the negative k direction. Then we can solve that for our unknown components. Using those components we can find the magnitude, and finally putting each component over the magnitude, taking the inverse cosine, gets us the coordinate direction angles.